Hi, high school students. My name is Rachel Long, and I will give you a presentation on Earth's climate through time. I wanted to start off by talking about the medieval warm period. This occurred approximately 900 CE to 1300, which is roughly coinciding with the Middle Ages in Europe, in which relatively warm conditions are said to have prevailed in various parts of the world through the northern hemisphere from Greenland eastward through Europe and parts of Asia. During the medieval warm period, an increase in solar radiation and decrease in volcanic eruptions created a La Nina-like event that changed the usual patterns. Stronger trade winds pushing more water towards Asia created wetter conditions in Australia, droughts in the southern U.S. and South and Central America, and heavy rains and flooding in the Pacific Northwest and Canada. The increase in solar radiation also modified the pressure system over the North Atlantic Ocean, which brought warmer weathers and wetter conditions over the northern Europe and most of northeastern part of North American continent. These conditions also affected the winter weather in Greenland, North Africa, and Northern Asia. I also want to talk about the Little Ice Age. This occurred earliest 14th century through the mid 19th century. This actually occurred after the medieval warm period. Mountain glaciers expanding at several locations, including the European Alps, New Zealand, Alaska, and southern Andes, and more annual temperatures across the northern hemisphere declined by 0.6 degrees Celsius or 1.1 Fahrenheit relatively to the average temperature between 1000 and 2000 CE. It is believed that cold conditions in different regions during the Little Ice Age might have been the influence from the explosive volcanic eruptions, such as the eruption of Laki in Iceland in the year 1783, and again on Sumbawa Island in year 1850. When the volcanoes erupt, they propel gases and ash in the stratosphere, which then reflect the incoming solar radiation. Now, we're going to get into how can they record this stuff? How can they figure out all this stuff that happened so long ago? And that's when climatic proxies come in place. Proxy data is the study of past climates. Scientists use what is known as proxy data to reconstruct past climate conditions. These proxy data are preserved physical characteristics of the environment that can stand in four direct measurements. The first proxy data I want to talk about is ice cores. Ice cores are located high in the mountains and near the poles. Ice has accumulated from snowfall over many millennia. Scientists drill through the deep ice to collect ice cores, which often have distinct layers in them. These layers contain dust, air bubbles, or isotopes of oxygen. Differing from year to year based on the surrounding environment, they can be used to interpret the past climate of an area. Ice cores can tell scientists about temperature, precipitation, atmospheric composition, volcanic activity, and even wind patterns. One negative thing about ice cores, though, is some care is needed in interpreting the results. This is because while the snow is being compressed into ice, gas transfer may occur between the atmosphere and the layers of ice. Indeed, dating information is sometimes given for the ice age and gas age because the gases in the atmosphere are mixed and decay over time, and this adds another element of uncertainty. Another one I want to talk to you is tree rings. Trees and their unique rings also serve as a proxy data because climate conditions influence tree growth, patterns in tree ring widths, density, and isotope composition reflect various variations in climate. Also, this one comes with some negative also. If they do not accurately represent the late 20th century temperatures, how can we be sure if they accurately represent temperatures in earlier times for which we have no instrumental corroboration? While this phenomenon is well known among tree ring experts and has been described in the scientific literature, the fact that this discrepancy between narrow tree rings and higher temperatures has not always been made clear has led to a lively debate. that is all I have for you guys. If you guys have any questions, just let me know. Thank you.